So far we've used truth tables to look at one sentence at a time. So the truth tables told us the truth value of that one sentence on every possible valuation of the sentence letters that were needed to make it up. This week we're going to continue with truth tables, but we're going to start looking at things truth tables can tell us about sets of sentences, as well as some more things with single sentences. So the aim of this lesson will be to look at some of these further uses for truth tables. We're going to use them to determine if a sentence of truth functional logic is contingent, or a tautology, or a contradiction. If a pair of sentences of truth functional logic are equivalent, and if a set of sentences is jointly satisfiable or unsatisfiable. So far, we've used truth tables to test whether sentences are true or false on each of the possible valuations of the simple sentences that are included in them. So remember that the different valuations are represented in the rows of the truth table under the simple sentence letters in the first few columns. Understanding what a valuation is going to be important for the definitions we're characterizing in this lesson, and they give you the instructions for how to use a truth table to test these various properties we're going to look at in this video and the next one. If you need to, you might want to review the concept of evaluation. That's a valuation as opposed to evaluation. What we're going to discover is that we can test these other properties of individual sentences, among other things. So for individual sentences, we can ask whether or not they're contingent, whether or not they're a tautology, whether or not they're a contradiction. Some of the concepts we're going to use to define these properties should be familiar from lesson video 1.5. That's where we covered some of these core logical concepts. Again, that might be another one worth reviewing if you've forgotten some of these since we haven't used them for a while. So one of those concepts was the idea of contingency. So we can test for contingency using a truth table because a contingent sentence will be one that's true on some valuations and false on others. So in some rows of the truth table it will be true, and in some rows it will be false. And that tells you that depending on the circumstances, that sentence may be true or false. Contrast that with tautologies and contradictions. Tautologies are sentences that are true on every valuation, so in every row of the truth table. If a sentence of truth functional logic is a tautology, so if we can prove that it's true on every valuation, then it's a necessary truth. So again, that notion of a necessary truth was one of those concepts we introduced before. It's important to note that there are some necessary truths that we can't characterize with tautologies in truth functional logic. But it's still true that if we have a sentence of the logic that we can prove is a tautology, then that will be a necessary truth. Any sentence that takes that form, in fact, will be a necessary truth. On the other hand, a contradiction is a sentence that's false on every valuation. So it will show to be false in every row of the truth table. And if a sentence of truth functional logic is a contradiction, then we know that it's a necessary falsehood. That sentence and anything that can be constructed from its form will be a necessary falsehood. And again, as with the relationship with tautologies and necessary truths, some necessary falsehoods can't be characterized with contradictions in truth functional logic. And there's some examples in the text. But again, all contradictions in truth functional logic will turn out to be necessarily false. So here's the kind of thing we can test with a truth table. We can ask of some sentence, is it a tautology, is it a contradiction, or is it a contingent sentence? So our first example will ask us to look at this sentence. It's a disjunction as the main connective, and it's disjunction of A and B or not A and B. So we can construct the truth table, and then we need to look at the truth value under the main connective, which gives us the truth value of the whole sentence. Here I've included the completed truth table for this sentence. Each row, again, is one of the valuations. We have to look at each valuation and determine if they're all true, all false, or some true and some false. So that corresponds with tautology, contradiction, and contingent sentence, respectively. The column in red in this truth table, under the main connective, that shows that this sentence is true on every valuation. So this sentence is a tautology. The three concepts we just looked at, contingency, tautology, and contradiction, all characterize individual sentences. The next three concepts we're going to look at describe features of two or more sentences. Equivalence is a property of usually just two, but it can be more sentences. And they're equivalent if and only if they have the same truth value on every valuation. And if sentences in truth functional logic are equivalent, then we know that they're necessarily equivalent. Again, the notion of necessary equivalence was covered in that earlier lesson. Equivalence in truth functional logic is a little different than necessary equivalence. So not all necessarily equivalent sentences can be expressed with equivalent sentences in truth functional logic. And again, another concept we covered in that lesson 1.5 was about joint possibility and impossibility. And again, there's a related concept in truth functional logic: joint satisfiability and unsatisfiability. A set of sentences is jointly satisfiable if and only if there is at least one valuation on which they're all true. So that tells us we have to look at each of the rows, each of the valuations, and there has to be at least one row where every sentence is true. A set of sentences is jointly unsatisfiable if there is no valuation on which they are all true together. So that means there's no row where we see true in every sentence column. The relationship between satisfiability and possibility goes similarly to the notions we've looked at so far. So if we know sentences are jointly satisfiable, then we know that they're jointly possible. And if we know that they're jointly unsatisfiable, then we know that they're jointly impossible. It just is the case that the reverse doesn't hold. There are some jointly possible or jointly impossible sets of sentences that we can't describe properly with this simple logic that we've looked at so far. So let's look at an example to see what it means to say, are all of these sentences true together or not? So the example is, are the following sentences jointly satisfiable or jointly unsatisfiable? And here we have a list of three sentences: A and B, not A or not B, and B or A. So the commas there separate 3 distinct sentences of truth functional logic. Now we're going to look at how to set up a truth table with multiple sentences. And it's going to build on what we did to set one up for a single sentence. First, we start by looking at all the sentences and determining how many simple sentence types we have. So in the first sentence, we have A and B. In the second sentence, nothing new. Only A and B again. And in the third sentence, we've got B and A. So no new sentences. In this case, in this example, there are 2 simple sentence types, A and B, across all of the sentences we're interested in. So those will be our first 2 columns, just as if you found only 2 simple sentence letters in a single sentence. And it so happens that in this example, each sentence has the same letters, but that may not be the case. In addition to our columns for the simple sentence letters, we're now going to have multiple columns for complex sentences. So each complex sentence gets its own column, so we can determine that whole sentence's truth value on the valuations in those left 2 columns. And again, the columns under the simple sentence letters are set up exactly the way they were before. You have 2 simple sentences, A and B. So you need 2 to the 2 rows. 2 to the 2 is 4, so we need 4 rows. And half of the first column should be true, so that's 2 true. And then half should be false, 2 false. And we take half of that in a row, so we get true, false, true, false. That pattern will always work to get you all the possible valuations, all the possible combinations of trues and falses. Just like with a single sentence, it's still important to identify the main connective. It's just that now you have to do so for 3 sentences instead of 1. The main connective in each sentence is highlighted here in red. Remember that when you're determining the truth value of a sentence, the value under the main connective will be 1, the one you determine last when there are multiple connectives, and 2, it will be the one that determines the truth value of the whole sentence. So that's the one we care about when we're trying to judge this property. Are these jointly satisfiable or unsatisfiable? Now we can determine the truth values of each of these sentences on each valuation, just as we would do for a single sentence. So we'll do each one of these sentences individually, one at a time. For the first sentence, the rules are pretty straightforward. We only have one connective, the conjunction. We know from the characteristic truth table that a conjunction is only true in this first valuation where both conjuncts are true. And in the other rows, it comes out false. The next sentence is a little trickier. It has multiple connectives. So to start, we need to find the connectives that apply to single sentence letters, since those are the ones that take narrowest scope, and we need to talk about and determine the truth values of the ones that take narrowest scope first. Then we can work our way to the main connective. So in this second complex sentence, the negations each apply to single sentence letters, and they take narrowest scope. So those are where we have to start. So for not A, we just take the truth value for A and swap it. And for not B, we take the truth value of B and swap it. And that gives us each of those rows. The only other connective in that second sentence, the disjunction, that's our main connective. We determine its truth value by looking at the truth values under the sentences it connects. So this disjunction links 2 negations. not A, and not B. This means we have to look under the negations for the truth values that our disjunction depends on. So in the first row, not A is false and not B is false, so the disjunction is false. In the second row, not A is false, but not B is true, so the disjunction is true. In that second, third, and fourth row, at least one of those two disjuncts is true, and we know from how disjunction works that as long as one disjunct is true, the whole disjunction is true. And now we can do our last column, since we've completed the truth value under the main connective for both the first and second sentences. And again, this is only one connective, and we know from the characteristic truth table for disjunction that it's only false when both disjuncts are false. So that will only be in that last row where both A and B are both false. At this point, our truth table is complete. We can then examine it to determine which of these two properties, joint satisfiability or joint unsatisfiability, this set of three sentences has. We'll look at each row one at a time. If there is any row, any valuation, where all three sentences are true, then they're jointly satisfiable. However, if there's no such row, at least one sentence is false in each row, then the three sentences are jointly unsatisfiable. In this truth table, there's at least one false sentence in each row, and you'll see them circled here. Since there is no row where every sentence in that row is true, there's at least one false sentence in each one. This set of sentences is jointly unsatisfiable. So in this lesson, we've introduced a few additional tests we can run on single sentences using our truth tables. And we've learned to construct a truth table for multiple sentences as well. And we can use those to test for equivalence, joint satisfiability, and joint unsatisfiability. In the next lesson video, we'll finally get back to arguments. We'll learn how to evaluate arguments using truth tables.